Hi, my name is RAUL MACHADO. I'm going to do the fourth assignment. This time is going to be fast because there are two parts. Okay, so the first is about draw a drag of a certain equation given assignment 2. As you can see there you have here the outcome, the treatment, the covariates there, and then the global Markov property specified by the d-separation of block criterion, the set of all conditional independence relations holding by any model associated with the graph. In this case, all the conditional independence relations are t, y independent of t giving x, and y independent of x giving t. The fork gives you this, y, and it's an ignorability assumption, and it separates the path ty. And the chain, y independent of x given t, is either the consistent assumption, create this, okay, and it separates the path xy, like, and the collider at y, makes the path x and t independent without condition, so it's not included, okay. Now, in exercise number 2, you have 4 drags. You replot it here using the package, giving the references, and the points to which is true or false, the statements, who separates, okay. So it's independent x1 and x3 for the 4 graphs. This is because the sources is that this is not, and this is because of sources, and here the same thing here in 1 and 5. This is because of the sources, and the others are based on whether it's a chain, a fork, okay. Many of them. So which part of it, if you see number 1, exercise number 1. Well, finally, for the same exercise, for each of the 4 groups, give a set of nodes that x and y are d-separated. The set of nodes in the case is x4, and in the case B x4, and in C the other 3, x2, x3 are the 4, and in the D is x4 only. Now, in exercise 3, we have 3 variables, okay? Draw a drag based on the independence discovered, okay? So let me specify a few things here. Correlation between 2 nodes doesn't give information about the direction of the arrow, only there exists an indirect line between the 2 nodes. That is, the skeleton of the DAG can be obtained from the correlations. The skeleton of the DAG is an indirect graph formed by replacing all arrows with indirect lines. The skeleton of the DAG based on the dependencies. I plot several DAGs in part B, okay? So, and the graph is the same and then the one because it's 2 things. In order to get the unique Markov equivalence. They have the same skeleton as exercise number 1, and the collider in exercise number 1 is not uncoupled because there is an edge between E and P, while there's no collider whatsoever in this one. This is only the skeleton. So hence they have the same Markov equivalence. The same for the part B. We'll tell you later on part B. Okay, here are part B. Let me put this picture here, and here is none of the association between the pair EI is negative. Reverse sign upon the condition of the third variable, regardless of the value taken by P, which is positive here. This phenomenon is referred to as Simpson paradox. It is like for instance, you have trends that may appear in several different groups of data, but disappear or reverse when these groups are combined. This issue is understood with causal inference. Okay, so now there's a correlation with the just give the skeleton of the graph. They already talk about that, but does not give information of the direction of the arrow. Okay, I mentioned that before. Hence, it could be that 2 arrows, the direction of the arrows are possible. That is, the answer is yes to the question that there are all the possible DAGs. Here, presented some of them. You see, but all the DAGs have the same skeleton of no direction, and their colliders are not uncoupled. Okay, so you see the colliders here, these two uncoupled here, the collider here is a couple, this H is a couple here, so they have a unique Marcus equivalence. Okay. Assignment number 2, part 2 of this. Assignment 4, part 2. Here we asked to when drawing, do calculus for x4, the incoming arrows of the x4 disappear. Okay, the resulting changes in the DAGs are, you can see here. Okay, so the effect of x on x3, x4 on x3 can be estimated with a condition on the other variables in the graphs B and C. Notice that you see B and C. Notice that the original graph given in A and D, it was the arrow were from 4 to 3. So I had, okay, from 3 to 4. So these have been changed, but the effect from 4 to 3 has no change. So there was no effect there, so I haven't changed that. The point is that you only intervene in the part that you're intervening. The rest same. Okay. Consider the DAG, this given DAG. Okay. I'm going to assume the following observation distribution. Okay, that match the causal structure represented by the given graph. Okay, the given graph, but doesn't give you the equations. Okay, so you write the equations. So for instance, this is a source. You have no source here, no source here. That's why I gave this noise here, and then the other dependency, where it's noticed there's no direct link between y and omega. Okay, so and then you have the simulation. You see the errors, noise, sorry, and then you get the simulation there. Okay. Okay. Now the do graph of this example. Okay, because this is a connection here. I have to get rid of the connection on that is incoming to W. That's why the begin isolated here. W gets isolated here, and then you get a fixed value here, or whatever number you're going to put there. Okay. But not so again. Notice there's no incoming arrows and to W that disappear, which isolate W because W has all arrows incoming. There's something very strange with this graph because there's no direct link with this. So if you're going to do causal effects, or the effect of W on Y should be direct link. Because this, I will tell you that later on. I'll talk about that later on. Okay. Note that the original given drag, there's no direct link between W and Y. And in this question, it is asked about the causal effects of Y on the mean of Y. That is this. The causal effects of, for instance, of an hypothetical W to Y is denoted by this. Can be calculated by applying the direct path method. There is a reference there, which consists of multiplying the weights at each path and adding the later those results from each. But there are no direct paths between W and Y in the original path. The two other paths, you can see here, the original path, the other two paths, these two, are not causal. Okay, I think there's an error in the DAX for this entire problem. Okay. Anyway, the other thing is I did a correlation, but there's no, all of them are biased because I'm blocking using backdoor, but there's no front door. So there's something missing in that DAG. Okay. But let me explain you this. The point is to study the regression coefficient of W that estimates the causal effect of W on Y. In the original graph, there is no direct link. Okay, I'll put it again here. And they are not blocked by colliders. Okay. There are two back doors, okay? But again, no direct link. This is something missing here. I set a variable that could sufficient control the confounder, assuming there was a direct link, would be X, Y, X, U, and X and W. Or X and W do this to X and U, or the combination of both. Okay? The regression coefficient of W that match the multiplication of the weights are unbiased. If there is a bias, means that there are other paths we are not controlling. If there is some bias, we are controlling the path, and we are blocking the blocking for confounders, okay? But again, I think something missing here, okay? Let's give you the percentage of the results anyway. You see, none of them give you 1 because I use the weights as 1, okay? And the same problem here, these remaining problems are still based on the original DAG, which seems to have missing edges. For instance, problem 4 is assume that you have access to the observation U, which can be interpreted as users hiding or latent variable. The strategy is to block the path through U, also known as vector adjustment, to get on bias estimator. But again, there's no direct path here, and the problem relies again on the DAG, but there is no link between W and theta. So how can you do the causal effect between theta and W? There's no direct path. Anyway, something is missing there. Thank you very much.